The next thing we're going to work on is the discriminant foldable. So it should look like this with some extra paper. So the first thing I want you to do is cut it, like so. You can do this with me. If you have to pause it when I'm done, you're welcome to do so. So you're going to have your foldable, and you're going to leave it just as is, and you're going to fold the left corner to here, the upper right hand corner to here. So you're basically making a kite looking shape. And it should end with this. Now, you're going to see I made mine really colorful. So, what I want you to put on the front, and we already I've given you a preview of this in the previous video. Discriminant equals b squared minus 4ac. Here we're going to talk about its relation to quadratic formula. Up here, discriminant equals 0. Up here, I'm going to model a problem what happens when the discriminant is 0. Right here, we're going to put discriminant. Discriminant is greater than 0. So this means when your answer is larger than 0. In the lower right hand corner, discriminant is less than 0. So obviously, again, I'm going to model a problem when it's ending with a negative number. So pause the video and prepare your front, and you can add some decorations on the sign if you want. Okay, so you should have already prepared this as I'm going to go through each one of these 4 corners. You're going to see on some of the paper, I'm going to model the problems just so you can understand the work a little bit more detailed and step by step. So in the first one, let me fix this so this is not, okay. In the first, and you can kind of see I had some whiteout issues. Okay, in the upper right hand corner, you're going to put the formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now at this point, you should know why my tone's like that, as that's how I'm going to be carrying it as I say the formula so you can remember it. Okay, so in the upper right hand corner, write the quadratic formula and how and why does the quadratic work. Okay, so if you're looking at the comparison up here, this should be able to make more sense. If you have a positive square root, say like 16, my square root is going to be 4. So that means I can do negative b plus 4 or negative b minus 4, which makes it a real number. In the second result, the reason is if this, let's say for instance, b squared, okay, wonder if it results with this being 16 minus 16, my answer for the center would be 0. So the square root of 0 is 0. So if I'm adding 0 and I'm subtracting 0, I'm going to have the same answer. So that's why that would be one solution. For this case, if I resulted with negative 16, that's not possible. You can't square root a negative number. Excuse me. Therefore, it's going to be no solutions. This will make more sense as I go through the video. Pause the video if you need to catch up with the notes. Okay, so the first one I'm going to go to is when I have, we'll do two solutions. I'll work my way around. So in the lower left-hand corner, I'm going to model what it looks like to have 2 solutions. So with this equation, and I kind of modeled this already, okay, if I were finding the discriminant, b squared minus 4ac, I took the b, which is 1 squared, minus 4 times 6. 6 is a, and my c is negative 15. Let me add that to my notes. Okay, so add that to that, so it's going to be the exact same color. Okay, so 1 squared minus 4 times 6 times negative 15. Okay, so 361 is going to be, this results with 360, okay, a positive 360 plus 1, which is 361. It's greater than 0, which means it's 2 solutions. And how that works, if I actually went through and worked it out using the quadratic formula, and that's a minus, I would be able to see that I have a negative 5 over 2 equals negative 3 over 2. Let's try to remember the purpose right now. I'm going to model the quadratic formula in the next video, so if you want to write this down as a reference for later. But the reason is I wanted to also show you the work. Even though this is unfactorable, you're going to understand why there's two solutions, and when you go to use a quadratic formula, it'll make more sense. How this looks on a graph, and we've talked about this one is our most common one. I have two solutions. I have 2 points on the x-intercept because it's crossing it, the whole parabola. And that'll make more sense as I go through all these. Pause the video if you need it to catch up. Okay, so I'm going to go to the lower right-hand corner for you to see what happens when there's no solutions. Now the same thing over here. I'm going to have details that I'm not going to expect from you. But let me explain this first. So if I'm using b squared minus 4ac, I do 2 times 2, okay, minus 4ac. I'm going to get 4 minus 20, which equals a negative 16. Negative 16 is less than 0. Okay, so therefore, it's going to be 2 imaginary solutions and no solutions. It's not that the function doesn't work, but as you can see, if I graphed it, it's in a place where it's not going to touch the x-intercept. Therefore, there are no x-intercepts. And for that to actually work out, okay, so this would be if I took the quadratic formula and found it. I have a negative 16. And these kind of solutions would be if you actually went through and solved this. I am not expecting this from you, but what I am expecting is that you can identify no solutions. So pause the video. I was trying to give you a second to get caught up. Pause the video if you need to catch up. And the last one is the upper right-hand corner. So this is what happens when you have one solution. Okay, so with one solution, I'm going to do b squared minus 4ac, same thing. I'm going to do 10 squared minus 4ac, which is 25, equals 0. Okay, so up here, x plus 5 squared, because if I went through and factored this, 25 over 10, and I'm going to see my two factors would have been positive 5. I go through and find x plus 5, I'm going to result with a negative 5. Therefore, I can't write negative 5 twice, so I'm only going to have one solution. I go to look at my graph, and the reason why this works, that means that the vertex is the x-intercept, and that it is only touching it once. Therefore, it is one solution. So, if you have this down and you understand it, you can end the video. I'm going to do one extra thing to go over this to make sure you understand. So, to look at this again, I'm going to do a review. So, if I were to compare these, sorry, ignore the loud noise, okay? I'm going to do, when it equals 0, which means, sorry, brain freeze, one solution. Okay, what happens when, let me zoom out a little bit, is greater than 0, which means 2. And what it means when it's less than 0. And there are none. Or proper way, no solutions. Okay, so for this case, and this is all pulled from the sheet. So when there was one solution, we had the equation x squared plus 10x plus 25 equals 0. And if I do b squared minus 4ac, I'm going to have 10 squared minus 4a, which is 1, c is 25, 100 minus 100, 0. Therefore, I'm going to have one solution. The next one, when there were two solutions, I had the equation 6x squared plus x minus 15 equals 0. B squared minus 4ac, I do 1 squared minus 4, 6, negative 15. Okay, so when I went through and did this, I get a result of 361. This is greater than 0, therefore there's going to be two solutions. No solutions. From the equation I use, x squared plus 2x plus 5. B squared minus 4ac. I'm going to do 2 squared minus 4ac. Okay, 4 minus 20 equals a negative 16. This is less than 0, so there are going to be no solutions. This is the end of this before we go to the quadratic formula.